Welcome to another video on function transformations. This video deals specifically with horizontal and vertical translations. So the goal of the video is to graph functions using horizontal and vertical shifts. So for looking at transformations from this function to this function, this video deals specifically with how C and D transform the function. Let's first talk about a horizontal shift, which means the graph will be shifted left or right. Y equals f of the quantity x plus c will shift f of x left c units, and y equals f of the quantity x minus c will shift f of x right c units. Now this may be the opposite of what you might think. If you add c units to x, the function will be shifted left, and if you subtract c units from x, the shift will be right. One way to get a feel for this would be to compare a table of values for f of x and f of the quantity x minus 1. So let's go ahead and do that. Let's choose x equals 1, 2, 3, 4. So to find y, we just square x for f of x. So this would be 1 squared or 1, 2 squared, which is 4, 3 squared is 9, and 4 squared is 16. Let's use the same x values for f of x minus 1. So now we're going to subtract 1 from the input and then square it. So 1 minus 1 squared would be 0. 2 minus 1 squared would be 1 squared, or 1. 3 minus 1 squared would be 2 squared, or 4. And 4 minus 1 squared would be 3 squared, or 9. So if we compare the y values of 1, 4, and 9, notice that for f of x minus 1, we have to increase x by 1 in order to get the same y value. And when we increase x by 1, we're shifting the function to the right. So when we subtract a number from x, it moves to the right, and when we add a value to x, it shifts to the left. Here's the graph of these two functions, and what you'll notice is for any corresponding point, let's say the vertex on the original function and the vertex on the shifted function, it's 1 unit to the right. Pick any point on the original function, and the translated function will be 1 unit to the right. Let's look at an animation of this. Here we have an original function in red, and as I change the value of c, you'll see the translated function in blue, as well as the function notation for the translated function. So notice when it's f of the quantity x minus 2.5, the blue function is shifted to the right 2.5 units. We can also compare corresponding points, and what you'll find is each one in blue is shifted 2.5 units to the right. Let's go ahead and see what happens when we change this to x plus a constant. You can see when we have f of x plus 1, the translated function is shifted to the left now. Let's go ahead and talk about a vertical shift now. Y equals f of x plus d will shift f of x up d units, and y equals f of x minus d will shift f of x down d units. And this translation probably seems more logical. Remember, f of x is equal to y. So if we add d units to y, the function will shift up, and if we subtract d units from y, the function would shift down. Let's go ahead and do another comparison using f of x and f of x minus 2. So again, for f of x, we'll just square the input, so we'll have 1, 4, 9, 16. For f of x minus 2, we'll use the same inputs, but now we'll square the input and then subtract 2. 1 squared minus 2 would be negative 1. 2 squared minus 2, that would be 4 minus 2, or 2. 3 squared minus 2, that would be 9 minus 2, or 7. And 4 squared minus 2 would be 16 minus 2, or 14. So if we do another comparison of the y values of the function, notice that all of the y values in red are 2 less than the y values in blue. Therefore, this function would be 2 units lower than the original. Here's the graph of those two functions, and so we can pick any point on the original black function, and to find the corresponding point on the translated function, we would just move this point down 2 units. Let's go and take a look at an animation of this as well. So as we change the value of d, we'll see how it affects the graph. The translated graph will be in blue. As we increase d, the function is shifted upward. And if we have f of x minus d, the function is shifted down from the original. Let's go and take a look at some examples. We want to be able to use what we just learned in order to accurately and quickly graph f of x equals the absolute value of the quantity x plus 3 plus 2. So the first thing we need to do is recognize what the parent function is. And in this case, it would be the absolute value of x. So let's go ahead and call g of x equals the absolute value of x. And let's go ahead and graph this for reference. Remember, the absolute value function forms a v. Looks something like this. Let's go ahead and identify a few of these points. This would be 2, 2, this would be 0, 0, and this would be negative 2, 2. The next thing we need to be able to do is recognize how taking the absolute value of x plus 3 and then adding 2 would translate the parent function. So what we could do is say that f of x is equal to g of x plus 3 plus 2, if that's helpful. Notice if g is just the absolute value of x, g of x plus 3 would be this part of the function, and then the plus 2 would be the constant on the end. So increasing x by 3 here, which would be the same as this x plus 3 here, would shift the graph left 3 units. Then adding 2 to the absolute value function here or here would shift the function up 2 units. So now what we can do is take these 3 key points and shift them left 3 units and up 2 to graph the given function. So let's do that. Let's start with the leftmost point. We're going to go left 3 units and then up 2. So we'd be over to negative 5 and then up to 4. Next, we take this point 0, 0 and shift it left 3 units and up 2. We'd be here at negative 3, 2. And lastly, we'll take this rightmost point, shift it left 3 units and up 2, and we'd be right here at negative 1, 4. Now that we know that the absolute value function is a v shape, we can form the new function here in green using translations. And it would look something like that. Let's go ahead and try another one. Again, the first step is going to be to recognize what the parent function would be. If f of x equals the quantity x minus 2 squared minus 4, we should recognize the parent function as, let's call it g of x equals x squared. So if we want to create f of x using g of x, f of x is going to equal g of, well, x minus 2 is being squared, so we'd have g of x minus 2, and then we're subtracting 4. Now after a while you may not have to write it like this, but it may help at the beginning to recognize that here we're decreasing the input of x by 2, which means it will shift it right 2 units. Recognizing this x minus 2 here is the same as the x minus 2 here. And then subtracting 4 from this function value would shift it down 4 units. So this minus 4 is the same as this minus 4 here in the given function. So to graph this given function, we should first sketch the graph of the parent function, g of x equals x squared. Let's go ahead and do that. Remember, that's a parabola with its vertex at the origin. So this would be the vertex. 1 square would be 1, 2 square would be 4. And then we have a mirror image on the other side of the y-axis. So we have a point here and a point here. So this is the parent function. And what we're going to do now is pick some key points here and then shift each of them right 2 units and down 4 units. So let's start with the vertex. We'll shift it right 2 units and down 4 units to here. Next, we'll take this point here and shift it right 2 units and down 4 units. That would be here at 1, negative 3. Then we'll take the point 1, 1, shift it right 2 and down 4 here. Might as well go ahead and do these last 2 points. Let's take this one and shift it to the right 2, down 4 would be here on the x-axis. And the same here, shift it right 2 and down 4, we'd be at the origin now. So the translated function would be this green parabola, as we see here. Thank you for watching.